When we think of explosions, we think of the things we can see. But what about the damage you can't see? That silent, ringing aftermath that follows millions of people home. Well, today, we're diving into the incredible science behind one of these invisible injuries and a groundbreaking attempt to actually reverse it. So why is this research so important? Well, you first have to understand just how big this problem is. That number you see, nearly 5 million, that's how many U.S. veterans are affected by service-connected hearing issues as of 2024. It's a staggering figure, representing so many lives changed by something most of us never even see. And this isn't some new problem, not at all. The U.S. Department of Veterans Affairs is very clear about it. Hearing loss is one of the most common disabilities linked to military service. And you know what the main cause is? Overwhelmingly, it's exposure to noise and to blasts. So what is actually happening inside the ear when a blast wave hits? Let's take a closer look at the hidden toll of this really powerful invisible force. This injury actually has a name. It's called blast-induced hearing loss, or BIHL for short. It's caused by that sudden, violent shift in air pressure from an explosion. That pressure wave just wreaks havoc on the delicate, tiny structures of your inner ear. And, while we often connect this with the military, it also affects people in construction or heavy industry, anyone working around high-impact tools, or even controlled detonations. This chart really puts the danger into perspective. Okay, so the recognized safe limit for a single unprotected impulse sound is 140 decibels. But just look at this. Even small arms fire is around 158. And heavy weapons, they can easily top 170 decibels. We're talking about an environment of just extreme, unavoidable acoustic trauma. Right, so if you want to find a cure for something, you first have to really understand the injury. And for scientists, this creates a massive challenge. I mean, how on earth do you study the effect of a bomb blast safely inside a lab? Seriously, think about it for a second. You can't just be setting off explosives next to your expensive lab equipment. You need precision, you need control, and you need to be able to repeat the experiment perfectly every single time. And the old way, using these massive shock tubes, is just wildly expensive and complex. So the solution these researchers came up with, it's absolutely brilliant. They solved it with this. It's a custom-built system based on a modified paintball gun. I mean, how clever is that? This is just a fantastic piece of scientific ingenuity. It uses compressed air to deliver a super precise, controlled pressure wave to a single ear, which perfectly mimics the kind of asymmetrical blast someone might experience out in the real world. So now that they could reliably and safely recreate the injury, it was time to test a potential solution. And this is where the science gets really, really exciting. The whole experimental procedure was super methodical. They take a mouse, position its left ear right at the port of the device, and then deliver 2 controlled blasts. Right after that, the mouse would get an injection, and then its hearing was carefully tracked for the next 2 months. Now, this potential cure is all about something called the BDNF-TrkB signaling pathway. I know, that sounds super complicated, but the best way to think of it is as the body's very own emergency repair crew for nerve cells. This pathway is great at fixing everyday wear and tear, but the damage from a blast wave, that's catastrophic. It completely overwhelms the natural crew, and that's why the damage becomes permanent. Okay, so this is where the potential treatment comes in. The mice were split into 2 groups. Group 1 got a placebo, basically a shot with nothing in it. Group 2 got a drug called 7.8 DHF. Now this drug, it acts like a kind of site manager. It shows up after the disaster and gets that overwhelmed repair crew, that BDNF-TrkB pathway, to get back to work and to work overtime. So the stage was set. The injury was delivered. The potential cure was administered. The big question is, did calling in that site manager to rally the repair crew actually work? First, let's see what happens with no treatment at all. This graph shows the hearing threshold. Just remember, the higher the line goes, the worse the hearing loss is. And you can see that after that double blast, the threshold just skyrockets, and it just stays there. The damage is severe, and it's permanent. The body's own repair crew just can't handle it. But now, look at this. Okay, that red line is the placebo group. No recovery, just like we saw before. But the blue line, that's the group that got the drug. You can see a clear, significant drop in that hearing threshold over time. The site manager drug actually worked. It successfully helped the body's own repair crew to start fixing the damage. It's amazing.
But, and this is really crucial to be clear about, the recovery, while it was significant, was partial. The drug made a huge difference for sure, but it didn't turn back the clock completely. So it's a really promising first step, but it's not a miracle cure. Well, not yet anyway.
So, what does this all mean for the millions of people affected by this kind of injury? Where do we go from here? Let's break down the path forward from this really promising research. Okay, so let's just recap the key points from this incredible journey. First, we have a brilliant new way to safely study this injury. Second, we know that activating the body's own repair crew is a strategy that actually works. This specific drug showed real, though partial, success in mice. And while it's not a silver bullet, it points the way for future research, maybe testing different doses or even delivering the drug right into the ear for a more powerful effect. You know, this whole research story is just remarkable. From a paintball gun in a lab to a potential drug that marshals the body's own defenses. And it leaves us with this huge, hopeful question. With more research like this, could we finally be on the verge of a treatment that makes this invisible injury visible and, more importantly, reversible?